We're asked to sketch some equations here, and you can see it starts kind of nice with just a quadratic, and then we get some modulus in there as well, which actually is even better. So let's look at part one. The aim is always to factorize. It's going to be x minus 3, x plus 1, with roots at 3 and minus 1. We're asked to include them on the sketches. So I'm going to put this one at 3 and this one at minus 1, roughly in the right place. It's going to be a happy quadratic because the x squared is the leading term. Just try that again. Okay, and you've got to make sure you make the turning point not at the y-intercept, because the turning point will be halfway between minus 1 and 3. It'll be at 1, in fact. I'm not going to calculate it, it doesn't ask for that, but yeah, just make sure it's nice and smooth like this. And the y-intercept is going to be minus 3. So that's the first one done. Second one is the same again, but we've got a modulus. So y equals x squared minus 2 times the modulus of x minus 3. Now when x is greater than 0, modulus of x is just x. And when it's less than 0, we get minus x, because then that ensures we get a positive result. If, for example, x is minus 3, we get minus minus 3. So I can split it into these two parts. I'm going to get x squared minus 2x minus 3 for x greater than 0, which is the same as above, in fact. I'm going to get x squared plus 2x minus 3 for x less than 0. I just need to look at that one in a little bit more detail. So for x less than 0, y is going to be x plus 3, x minus 1, which gives us a root at minus 3 and 1. Okay, so I'm going to draw it so it looks the same as, yeah, that's all right. 3 and minus 3. And then we're going to get a root at minus 3 with an intercept of minus 3. It's actually going to be a reflection. And it will look like this. And in fact, in this case, if you did take f of minus x, then you would get x squared minus 2x minus 3 when you put it into here, which shows it is actually equal to f of x, and it's simply a reflection in the y-axis. So that would have been a slightly quicker way of doing this question. I factorized it, but hey, I still got there. Let's take a look at part 3. Here we've got y equals x squared minus x minus the modulus of x minus 3. So again, I'm going to split it into its two parts. When x is positive, the modulus does nothing. We're going to get x squared minus 2x minus 3, which is the same again as before. So we can already see what that is going to look like. However, for x less than 0, the modulus is going to become minus x, so it'll become plus x. So it'll be minus x plus x, and we're going to get x squared minus 3 as our result. For x less than 0, y is actually going to be x plus root 3 and x minus root 3. The root of interest is going to be minus root 3 because that's the one that's going to be negative. So I'm going to get the same thing happening, and this was 3, and this was minus 3. But now I've got x squared minus 3 to draw. By the way, to be really careful about this one because when you have y equals minus x, for example, it just looks like this, and if you translate it, it's going to look like this. So the actual turning point is on the axis, and therefore there's going to be a kink. It's not going to come back around like before. It's going to look a bit like that. And then I just need to label it as minus root 3 here. Of course, on none of these graphs did I actually label the x and y axis, which I should do. So I'll just add them now. Okay, but that's a pretty cool question. When you think you've got the hang of sketching quadratics, just add the idea of a modulus to it. You might have done, will have probably have sketched the modulus function by itself, but here we're incorporating it into quadratics. In the final part of this question, we're asked to solve an equation. And you can see that part 3 is in there, and then there's something slightly different. Now, you could take a graphical approach to this. I kind of just think an algebraic approach will work just fine. So that's what I'm going to do. There's going to be two situations we need to look at: x greater than 0 and x less than 0, because that's just how we just use the modulus function slightly differently in those situations. So for x greater than 0, we'll get x squared minus x minus x minus 3 is equal to x plus x. And that will give x squared minus 4x minus 3 is equal to 0. Because I get a minus 2x here, I get a plus 2x here, I've minus the 2x from both sides. X, now we just need to think actually this isn't going to factorize. You can see that quite quickly. So x is going to be 4 plus or minus minus 4 squared minus 4 times 1 times minus 3, so it'd be plus 12 all square rooted over 2. That's going to be root 28, which is going to be root 7 times 4, or 2 root 7. And remember, I'm only interested in this here will definitely be bigger than 4. Root 28 is bigger than root 16. I'm only interested in the positive one, so it's going to be 2 plus root 7. That's going to be my answer. Reject. Negative. Since x is greater than 0. That just leaves us with looking at x as less than 0. And now it's going to be x squared minus x. Again, then it's going to be plus x for the modulus function, minusing 3. And then I'm going to get x minus x here. So suddenly it all cancels, and I've just got x squared. Right, those cancel, those cancel. I'm just getting x squared minus 3 is equal to 0. You could add the 3 and then take the square root, or we could just factorize like we did when we sketched it. Okay, and we'll get x is equal to root 3 or minus root 3. And this time we're going to reject that one. So two solutions to this. Don't need to draw a graph, just deal with it carefully. Well done.